So if we try to integrate this, if there's an e in the function, doesn't that kind of help you figure out what your u should be? Because we like for our integration to go the integral of e to the u du. So that's a good place to start, would be by letting your u be 4x. So then our du would be what? 4dx. Are we good? Yeah, that contains everything that we needed it to. So this really is the integral of e to the u du, which from your note card just turns out to be e to the u plus c. So this final answer would be e to the 4x plus c. Okay, so here, what would our u be? 5 minus 2x, good. And our du? Wouldn't that be negative 2 dx? Do I have that factor of negative 2? So when I introduce in a factor of negative 2, I also have to put one in the denominator.
So is that negative 1/2 e to the du?
Yes, so that's negative 1/2 e to the u du. So that would turn into just negative 1/2 e to the u plus c, which would really be negative 1/2 e to the 5 minus 2x plus c. Anybody need a minute?
Are we gonna have trig in this today?
Example 3.
No.
E to the cosecant of x. Sorry, this is 5. No, we're not doing arc sine today. No. No arc trig. So let's try the antiderivative of e to the cosecant of 5x. Cosecant 5x, cotangent 5x, dx. Now isn't that a nasty looking integrand?
No.
Yes.
Yeah, looks like what we're trying to integrate here is just ridiculous. But it works out really nice because your u would be cosine of 5x. Our du, be careful here. What is the derivative, yes, of cosecant of 5x?
5 cosecant cotangent.
Yeah, that's
Cosecant x, cotangent x, and I need a negative.
Yeah.
So you remember the chain rule because, oh wait, there should be 5s in here.
Yeah.
So it should be negative 5, cosecant 5x, cotangent 5x. So that works out very nice because now doesn't this turn into, ooh, not quite.
You gotta add a negative.
Introduce a negative 5 and negative 5 in your denominator. So that'll integrate to just be negative 1/5 e to the u, which would really be negative 1/5 e to the cosecant of 5x plus c.
Keep going with the trig.
Just gave you the advice of letting u be the exponent. But if we let u be 2x in this problem, does that help us? No. So let's think about another u value. How about if we let u be e to the 2x? Good. Because then what would my du be? 2e to the 2x. And isn't that nice? Because I have that additional e to the 2x here. So I need to work in a factor of 2 over 2. So then this becomes the integral of 1/2 sine of u du. Yeah? Is that right? You good with that? So what is the integral of sine of u?
Negative.
Negative cosine of u plus c. So you get negative 1/2 cosine of e to the 2x plus c. What do you notice about this problem that's a little tricky about it?
The denominator.
It's got this denominator of e to the 2x. And does that numerator match with an e to the 2x?
No.
No. So any suggestions about what a u should be? Would you start out trying to do a u substitution?
Yeah.
Okay. So you might let u be 2x. Does that help?
No.
No, I've got all this extra stuff. That doesn't help.
Try the numerator.
Okay, so try letting u be the numerator. Does that help? No. So now I have to take a different approach. The way this fraction is written, could you split it up into two fractions?
Yeah.
Yes? So couldn't we rewrite this as 3 over e to the 2x minus e to the x over e to the 2x? Right? Now couldn't I rewrite this as 3e to the negative 2x? Is that acceptable?
Yes.
Okay. And then minus, what do you do with these exponents when the bases are the same?
Subtract.
You subtract them. What happens to x subtract 2x?
Negative.
E to the negative x. Now, could I separate this into two integrals?
Sure.
And now try a u substitution. Aren't each one of these integrands something we could do a u substitution for? Much easier than what we started with. Okay, so for this one, our u value would be negative 2x. Du would be negative 2 dx. I don't have that negative 2, so I'm going to introduce a negative 2, top and bottom. So this one will become the integral of negative 3/2 e to the u du. So is it the integral of that just negative 3/2 e to the u plus c? I'll take care of that c in a minute. Now over here, what would this u substitution lead us to?
Negative.
Yep. And then du would be just
Yeah.
negative 1 dx. Do I have that negative 1?
Yeah.
You could look at it as being outside here, Aaron. Yes, you could look at it that way.
I added one on accident.
Okay.
I know that.
So depending on how you look at it, you may recognize it's already there. If this was a plus and you have the negative inside of here, you would already see that it is there. If you've got it written this way, then we've got to change it to subtraction of negative e to the u du. What would happen to these two subtractions? And that becomes positive e to the u. Now, are these u's the same u's? No. So make sure you're keeping them straight. So this would turn out to be negative 3/2 e to the negative 2x plus e to the negative x plus c. I'm gonna let you try one just like this in a second. I wanna do another example for the video, and then I'll give you one of these to practice. So you can practice splitting one of these up and see what you can come up with, but let's get, another example in. Is this an integrand that I could split up into two fractions?
Yes. Wait,
No.
no, it's not, no.
Because your entire denominator is 5 plus e to the x. So you cannot split this one up into two fractions. So any suggestions about u?
5 plus e to that.
5 plus e to the x, du. So this would turn into the integral of du over u, which would just give us ln of u plus c.